Welcome to the future of mobility powered by JSW Steel. Now, in this series, we are looking at what it takes to make a car, future trends, and new practices. And to kick off this series, we are looking at the manufacturing bit. What goes into actually making the car on the assembly line? Now, today we are at MG Motor India's Halol plant. We're going to be taking a walk around. And with me is Biju Balendran, the Managing Director of MG Motor India. Biju, thanks for having me here. Obviously, a plant is where it's at. This is where cars are made. So let's just have a walk around and you can tell me, what goes into making a car.
Thank you, Hormazd. It's really a pleasure, and I want to thank you for coming down to MG Halol facility. It's a very, very old facility, but a very, very modern innovation activities are taken place in this plant over the last few years. And what I want to bring to you is this plant makes car which is a high-tech car.
Right.
So when the car is high-tech, the process behind is also really high-tech.
Right.
And that's the biggest, I don't call it as a challenge, I would call it as an opportunity for all of us to learn and deliver something different to the customer.
But tell me, in a plant, normally it's all about productivity, efficiency. How do you manage that? And there must be challenges also, because this wasn't originally a greenfield plant. It was an existing plant. So a lot of things had to be kind of probably reorganized, to put it mildly. And then, building capacity also within here, making things much more efficient.
Yeah, I totally agree with you that productivity is the key. And we have adopted many of the basic, or you can call the key principles of manufacturing, whether you call it lean manufacturing systems or smart manufacturing, or even we have gone into the industry 4.0 and 5.0 concepts also in this plant. We're really surprised to know that digital twinning is one of the biggest strengths for us, which we adopted in the paint shop.
Right.
So these new technologies, even online, real-time monitoring the data, to analyze the breakdowns, analyze the problems coming up. This has been adopted in this company now, in this plant now. So these things are really a strength for us to deliver a good quality car.
Yeah, I want to talk about quality. Because really, that's one thing which, there's so many moving parts in a car.
Yeah.
So much scope for things to go wrong.
Yeah.
I think it's all down to the processes. Of course, the people as well, because in the end, it's the people who make cars, not necessarily the machine. So just want to talk a little bit out on quality and maybe a bit on the workforce also.
Fine. Quality, let me tell you, our philosophy is first time right. I think, and that's everywhere, but we take it very strictly and very, in a very dedicated, committed way. You can notice our workforce is a very young workforce, with below 25 years of age.
Right.
And and we have very high diversity also.
That's what I've noticed. It's great to see there are a lot of women.
Diversity
there.
And diversity this year, currently we are at around 36%. We want to cross 40% by the end of this year. And that's the biggest advantage and biggest benefit for us. We find that many of the precision works, many of the intricate works are taken care of very, very precisely by this young crowd.
Right.
And it's not that there is no job in this plant which is defined only for ladies or only for men. The jobs are all ergonomically given a green station so that anybody can operate it, whether you are tall or short or women or men, it is designed ergonomically. So we have made sure that when ergonomically it is perfectly well, our deliverables as quality will also be good. That is the point of view of plant. But frankly speaking, that quality is not confined to plant. It starts from the raw materials selections to the supplier, to the plant,
right,
and goes beyond that, delivering of the cars to the customer, and even at the field, how we deliver to the front customers. So the whole process we have streamlined, and we have checkpoints at every stages, how to support or keep quality first as our criteria. And at any point, if we find anything is wrong,
right,
it's not that we rectify or correct that particular situation, but we go back and check the batches and make sure that a proper cutoff is done and customers are protected.
And, what's the level of, for quality where sometimes you need some automation also to kind of make sure that there's no variability in the processes. People don't make too much of, errors and that sort of thing. So, is automation quite important here? I don't think you have too much of it, but, or is it really down to the workforce, which is the most important factor in delivering quality?
Let me put it like this. in automobile, in auto manufacturing, there are certain quality sensitive assemblies and quality sensitive parts also. You can do wrong part of assembly also because there are so many variants.
Right.
All those places we have sensors and cameras to ensure that wrong part doesn't get into the car. So that sensors and cameras takes care of that.
Right.
Now when it comes to quality sensitive operation, take for example in body shop, there are certain welding, certain hemming, which has to be, which cannot be consistent with the human hand.
Correct. That has to be kind of
and those are robotic.
Right. Got it.
So,
That's
so
what
we
I'm getting at.
know which areas are sensitive for the quality
Right.
in terms of selection for the variants or in maintaining the quality. We are automated with sensors, cameras,
Right.
and robotics. So that's taken care.
Right. And even with your volume, to be honest, it doesn't make sense to go in for
High-end.
high-end robotization.
You know, we don't care. We don't go for that. Yeah.
Right. And, again, lastly, just talking about the workforce, what's the sort of training that's required? And, if you could just share a bit of that, because I think clearly it's always down to the people, and that's what is quite critical.
Yes. I would say today with making a high-tech car, our car, Hector, was the first internet car. And we all focus that training of the workforce is very important. And it is the most important thing, and we are focused on that.
So talking about new technologies, to be honest, cars are getting more complicated, especially on the software side. And then frankly, that's where there's a scope for, I wouldn't say errors, but there's a lot of learning which is new to the entire auto industry. And is software really one of the big challenges? You talk about internet inside very proudly, but software can throw up its own challenges, which you've seen is a problem, globally for the auto industry, especially as we are moving more towards electrification.
Yes. Software is definitely a challenge. I don't deny that statement. But what I like to tell you is we have a system, we have commonized the iSmart systems and the softwares in many of our background. So any problem we identify in one car, we try to map it to the other car, can it happen or not?
Right.
And we map it to the new car that is going to be launched also.
Right.
So this helps us to iterate and bring down the problems that the customer may face.
So you've talked about software, but a car is hardware. It's about metal. That's what cars are about. So let's go to the press shop and see where the heart of the manufacturing really is. So press shop, what I love about it is, every car starts life as a sheet of steel.
Yeah.
And then you just mold it, stamp it, and it gets these shapes. And I think that's really, in a way, the heart of manufacturing.
Yeah.
So, I just want to talk on the press shop, its role. How is it kind of evolving now? Obviously, again, important for productivity, but not so much of a bottleneck, let's say, like a paint shop is, for example. Is this very scalable? What are the new techniques being used? And clearly, with steel, productivity is very, very high, unlike other materials, I'm sure.
Yeah, let me put it like this. We have two press lines now.
Two press lines.
Two press lines we have, and it's a 5 press machine both sides.
Right.
What we do, a normal concept is that the cover parts, the outer parts,
Right.
normally pressed in-house.
Right. And you call the Class A.
The Class A, all the GI parts, outer parts we do in-house.
Right.
And the inner parts we try to do in-house. The big parts are there because big press we do in-house.
Or something from supplier.
And others we would outsource it outside suppliers who are working along with us parallelly in a just-in-time basis.
Got it.
Okay. Now, when we come to capacity-wise, this press shop does not work on jobs per hour. It works batch.
Right.
So it works in batches. Normally, it takes a batch of 300 to 400 car sets, stamps at one shot. And normally what happens is, when we say the die change time, the one
on the
die where you find here,
Right.
around 13 minutes you can change the whole thing.
Right.
And then you have the first few trial stampings happening, and then this pressing starts off.
And there are multiple stages.
Stages, multi-stage starts off.
Right.
We'll check the first and the 100th and 50th samples at regular intervals. Of course, some common inspection will be there. Damage there, we'll check every 100 or 50th or at regular intervals, and make 300 to 400 samples we make and store it.
Right.
That's normal standard we follow. And that goes on for 30 to 45 minutes or maybe 1 hour it goes.
Right.
That's the standard of batch production. And that's the strength of press shop, that we don't have to work on a particular variant or particular specifications. Okay.
Right.
Now coming down to the steel, the most important thing for us is that formability. You form in the press, and the design is so important that it should not crack.
Right. The draw as well.
The draw formability, we'd call it.
Correct.
So when you look at steel, you want the strength.
Right.
That's very important. You want the weight to be minimum.
Right.
You want the formability to be there, because you should give all the unique designs that we have, styling design we have on the car.
Correct. All the sharp edges.
It should come perfectly without cracks.
Correct.
So these are some of the key parameters, key things, the design that decide the design of dies,
Right.
the press, and then the output comes out of that.
Right. And really, and is it fair to say that as a material, steel gives you that level of flexibility and draw?
Yeah, it gives us. And nowadays, we are also gone, it's not just the outer parts, skin part we talk about. Today, the question of strength comes, and the strength to weight ratio comes.
Right.
Now we have to bring down the weight of car. Now the new technology that's coming in is the hot stamping.
Right.
And to tell you frankly, Hector had 2 hot stamping parts.
Right.
Aster had 4.
Right.
Comet has 17.
Wow.
And the new car that we're going to launch is much more than that. I'll
Right.
come back to the number later, because we are still doing trials on that.
Right.
And what is the hot stamping is that cannot be pressed in this press.
Right.
That's totally different concept itself. The blanks that you see the beginning of the line is heated.
Right.
Temperature of around 800-900 degrees centigrade, and then it comes to the die. It is formed at high temperature, and in that die itself it is quenched.
Got it.
So you get the mechanical properties at a high temperature quenching first, at a low, at the high strength you get at a lower weight, and that is the biggest advantage. And now most of cars are going into that sphere of hot stamping.
Right.
And we are encouraging suppliers to put up this plant near our facility, so that we'll have less inventory, and we are going to have more hot stamping in our future cars. You saw the growth.
Got it.
Towards 17 and going up now.
Got it.
And this is normally used in the car, maybe in the roof line or in the A pillar, B pillar,
Right.
the door beams. So this helps a lot in our safety of the car.
And Biju, what's your view on coated steels? GI, GA going forward, and just to understand.
Yeah.
Also the future role of the press shop. Yeah.
Like, let me put it like this, very simple way. Most of the outer panels are normally coated.
Right.
Now you have GI, you have GA.
Right.
Both are galvanized.
Right.
But GA, you have annealing done, extra process done.
Correct.
Now, to my knowledge, annealing helps us. The GA steel gives a better formability.
Right.
One more quality. It's slightly rougher than GI.
Right.
Not rough, but slightly rougher. This gives a better paint adhesion and a matte finish.
Got it.
This is the story behind the
Right.
GA.
Right.
But we are able to achieve the formability in GI.
Right.
So all our steels are GI.
Got it. All your steels are
GI at this point of time.
Got it.
So that's how we are working on our designs. Because all these are taken care at the design stage itself. So if we change from cold roll to GI to GA, it also impacts our body shop. The welding parameters on the guns, everything has to be accordingly suitably changed and altered. So it's a full process. So right now our design is based on GI.
You can explain that to me on the
So
stamp.
this is the examples of our outer panels,
Got it.
which we have just for display, and also to show the level of accuracy. The errors in that panels.
Right.
So these are the way the forming is done, and it's made for Model K, and this is for right. So the outer finish is very important. If you have any dents or any burrs, and that's going to become more magnified when you paint the car.
So this is what you are talking about, your different coat. Yeah. Okay.
Coated, GI coated steels.
GI coated.
Yes.
Okay, fine.
So the guys what they do inspection of the panels to ensure that there are no dents or burrs.
Right.
So if that happens, this will have a reflection on the paint shop. Right. And that's something which customers are always depend on that.
So clearly, you all are most comfortable with steel as a material.
Yes,
You all know it well. It's been evolved over years and years.
Yeah.
Still, I think the challenge really is to make it as lightweight as possible.
As lightweight as possible.
And retain the strength and properties.
Strength and property.
Yeah, and that you can achieve with things like hot forming and
hot stamping is one of the technology, and I take care of all the stiffener parts, everything.
Right.
That helps us in bringing down the weight of the steel and weight of the car.
Right. What about things like tailored blanks? I mean, is that something which one would look at future, where the thickness of the steel varies across?
We have not thought of tailored blanks.
Right.
So what we do is we do wavy blanks.
Yeah.
To reduce the grip area is optimized.
Right.
Of the dies. And that brings down the amount of steel used. For example, let me give you a high level calculation. Normally the body weight of the car when it goes out of the body shop is around 400 kg to 500 kg on average.
The BIW.
BIW is around that kg. The amount of steel that goes in to make that 400 500 kg car is around 800 kg steel.
Wow.
So almost 40% is wastage. So if you can reduce 5% also is
Of
big
that
thing.
wastage, yeah.
Big thing.
Right.
Okay, so
Why is it wasted? All the trim area, all that is...
when you have a cut sides. For example, if you have a roof, the sunroof,
Right.
it's gone.
Right. Oh, yes, of course. Yeah.
The windows of the door is gone.
Right.
So now
they have to be cut out.
cut out.
Because it's a one...
Big piece gone.
Right.
Then the engineering point of view, we work on how to reuse the sunroof part to make a fuel lid. Or,
that's very innovative.
yeah, that's the what we call VAV we do in the plant.
Right.
So our guys, they have a separate shooter below to collect those parts and give to suppliers and make a VAV engineering on that.
Right.
So these are all the innovative things what the plant does on the ground.
Got it.
So that's why you have wastage a huge amount.
Yeah.
But we try to deal that.
And Biju, lastly, while we are on it, BIW to weld shop, of course. So how obviously what you stamp over here has to be conducive for efficient welding, the strength and all that. So if you can just run us through the process from body shop stamping, to welding. Okay, that's the next stage.
Fine. Let's go to body shop and I will show you over there.
Yeah. So Biju, now body shop where the welding gets done, again a pretty, let's say, precise process. A lot of spot welding, different kinds of welding, maybe even some seam welding. So just if you can just run us through, the importance of this and what are the future trends really?
Yeah. Now, body shop is the place where the car gets into shape.
Yeah.
And one always thinks that body shop is a place where you have the weldings done, but there are many more operations which to be done other than welding also.
Right.
For example, all the doors have got something called hemming.
Right.
And I'll just show you one of them.
Right.
What is hemming means? The inner panel and outer panels are mated and then they are bent. You can see a bend is happening.
Got it.
Yeah.
Got it.
And that bend is happening. And that's very important because that's how you made two panels. There's a sealant in between that. If that is not done perfectly, if there is any accuracy problem in that, variations comes in, it impacts the paint shop. You will have bubbling happening there. Or even if it will also impact your door closures and all the efforts also.
Right, and just you can sum up what are the number of welds, because welds also give the stiffness, but also that's where the corrosion can happen.
Yeah.
So very, very important part of the whole process, the welding. And, are there some, you have multiple spot welds, do you also have some seam welds, all that. So just if you can just give a quick run through.
Yeah, just need to tell you on a car body, normally, I'm not taking any specific car, around 2,500 to 3,500 welds will be best. Wow. Will be there. That's the welding required.
Right.
And you can imagine that welds have to be good, because if the welds are not good, you will have your safety is impacted.
Correct.
So now what we do is we have tear down tests done at regular intervals. We do a chip test to make sure that the welds are perfect at every point of time. The quality of the tips of welding has to maintain.
Right.
At a certain level, that has to be grinded, that has to be maintained well. If those things are not maintained, the quality goes off, the strength goes off, and then you have the safety issues in the car. So this is a very precision areas where the final body gets shaped before it goes to paint shop. Paint shop is basically giving the looks, luster, and the nice welcoming feel to the car.
Right.
The real strength of the car comes from the body shop.
Right. So as you can see, making a car is a highly complex business. It involves an interplay of precision manufacturing, large-scale, high-quality materials, and all of it comes together to make the car that you finally see in the showrooms. And Biju, thanks very much for really giving us a fascinating insight into this. But before I let you go, it's a new innings for MG India with the new partnership or the joint venture with JSW. What does that mean? I'm sure it must be quite exciting and lots of opportunities.
Yes, it's really exciting and a lot of opportunities, not just opportunities, but also we find that the investments are coming through, our expansion plans are rolling out, and new portfolios are being frozen. And I think our roadmap for next midterm of 5 years is almost frozen. We know what we're going to do, where we are going to end up, and where we are heading towards. Which area we want to focus. Everything is getting narrowed down, and clear direction is coming up with the money coming in, with the support coming in, and we're all excited for this new journey, MG 2.0 to the next level.
Wish you all the best.
Thank you
so much for coming.
Thank you.